Welcome to Team 5's presentation for Barlow Respiratory Hospital's investment opportunity for health monitoring system. The American Hospital Association acknowledged that the over 65 population will triple between 1980 and 2030, with the first baby boomers turn 65 in 2011. Although the health and lifestyle of people at age 65 is very different than it was in generations past, it's even been said that 60 is the new 50, the reality remains that chronic conditions continue to plague the population. In fact, the American Hospital Association reported that more than 37 million boomers will be managing more than one chronic condition by 2030, with 1 out of 4, or 40 million, living with diabetes. Almost half will be living with arthritis, and more than 1/3, or over 21 million, will be classified as obese and living with all the health risks associated with obesity. At the same time, healthcare and hospital care spending keeps growing. In fact, national healthcare expenditure per capita is over $8,900, while Americans are growing less and less healthy. Hospitals across the country are looking at ways to become more efficient and reduce healthcare expenditures while providing more accurate diagnostics and knowledge-based treatments. The hospital industry functions through many interactions with several other healthcare industry participants. According to the Wharton School study of the healthcare value chain, the 5 major entities involved in the value chain are the buyers. The buyers are the payers and the intermediaries. The provider, which is the hospital. The supplier, the purchasers and producers of medical equipment, drugs and medications, and other material goods used by the hospital. For over 110 years, Barlow Respiratory Hospital has been relying on its valuable value chain system and experience to serve the Southern California community. It has evolved into a private, not-for-profit, 105-bed, long-term acute care hospital with a wide-ranging and distinguished history of providing respiratory and specialty medical care services to Greater Los Angeles and the surrounding Southern California region. Barlow Respiratory Hospital's ASIS process for admitting and caring for new acute care long-term patients includes 6 entities that work through processes to admit, evaluate, medicate, test, and provide care for a patient. Before the patient is admitted to the hospital, the admitting department, upon receipt of an external referral, makes the decision of whether the patient is eligible or not. If not, this ends the ASIS process. If yes, the patient is then assigned a doctor that evaluates the patient, orders lab tests, and prescribes medications. The nursing department administers the medication, and after the laboratory completes its orders, the patient is sent to the respiratory department where the TIPS protocol is used for weaning patients from ventilators, or respiratory care is given. The patient's doctor decides when the patient will be discharged, and the patient leaves the hospital to go home or to a nursing facility. All the while, the patient's electronic medical record is updated by each department and stored in the hospital's data warehouse. Our new process keeps the current process as is, and will add new Internet of Things monitoring devices to patients as they leave the hospital. Patients will be trained on how properly use their at-home devices. Information from the home monitoring devices will be collected in the form of structured data and unstructured data. This new process also adds infrastructure in the form of a Hadoop cluster, where predictive analytics will be used within the information that is fed to the remote patient dashboard. Dashboards located in areas of the hospital will provide information patients both internal and external to the hospital. The new technology allows for doctors to assess patients' conditions both remotely while the patient is at home, and for current hospital patients. The use of predictive analytics to find trends over time in existing data will benefit current and future patients. Our goal is to have a scalable Hadoop solution that will enable us to provide big data capabilities that Barlow will need in order to implement our knowledge-based medicine initiative as indicated by the graph. In fact, Our big data solution will be made more cost-effective with servers from HP, Dell and EMC, who offer quick and scalable storage solutions, as well as Cloudera, who offers affordable cloud solutions. We turn to Hadoop for collecting and processing information sent by our remote monitoring devices, to process large amounts of structured and unstructured data using multiple parallel servers. This powerful open-source platform will allow Barlow to simultaneously analyze data coming from patients' tablet, Facebook posts, Twitter mentions, health tracking and monitoring devices, emails, picture etc. The data are then distilled down using MapReduce in order to allow distinct elements of patients' single health to be visualized and analyzed, allowing Barlow to mix historical data and current symptoms to derive insight in order to improve patient care. The data are then consolidated into a business view that can be viewed at the application layer. Clusters of data are consolidated by specific annotation and used to serve different departments. Our methodology includes the phased implementation of initiating a relationship with Barlow Respiratory Hospital from defining the scope, requirements gathering, project planning, operations analysis, and through an agile process designing and building an information system prototype that allows for feedback from the hospital staff and patients. Transitioning to the production environment and integrating the home monitoring system into the current information system, which includes the electronic medical record and patient information gathering tools. Once installed, the home monitoring system will be integrated into the current business process, and upkeep and maintenance of the new system will begin. A quality plan to meet the specific requirements of the project will be established. The quality plan will include the following elements: mission planning and advancement points. In this context, our project team will use standard techniques of the Program Evaluation Review Technique or PERT. Definition of indicators for monitoring progress and evaluating performance. These indicators will be shaped in various dashboards and highlight compliance costs, deadlines and benefits. These dashboards will be user supports for the real monthly meetings and monthly progress to reflect the progress of the project on one hand, and used as a guideline to follow the diagram of tasks throughout the project on the other hand. Monthly progress meetings and special meetings to inform everyone of the project progression, challenges and solutions. These meetings will be reported in writing. Risks related to the different tasks of the mission and appropriate preventive measures. Correction procedures to be implemented depending on the urgency exhibited at progress meetings or direct broadcast. Roles of the different stakeholders in the conduct of the mission at the earliest establishment of a list with the names, occupations, and addresses of the various actors. The project management method has two main objectives: quality control and cost control. Our timeline, as shown, includes 2 months for system requirements gathering and operations analysis. Beginning the 3rd month, solution design begins with a small prototype. Through an agile process of continuing to modify the system to the hospital's needs, the final prototype design is finalized by month 7. Then, the building of the system's hardware, software, remote Internet of Things devices, and integration protocols takes us into the 12th month when the hospital's information technology-enabled transformation begins. Production is the final process when the equipment is installed and remote monitoring devices are produced for use in patients' homes and nursing facilities. The proposed approach is to time the different phases of the implementation around the health monitoring system solution. It is split into phases from which each of one or more end products is necessary for the execution of the next phase. The first phase is to optimize the use of the products in their final environment and identify deviations from the expectations of users and procedures targets. These differences are analyzed progressively to determine the essential nature of the request, the impact on the cost and time of completion of the application. In view of this information, The decision can then be taken to perform or not to perform the missing functionality of the application as a custom application. It is only after deciding on each standard and testing the system as a whole that the entire application is validated. This is illustrated by the diagram below. Our assumptions are as follows. Barlow's total patient revenue for year 0 was $50,673,575 per the hospital's 2014 990 tax form. Thus we assumed 750 patients contributed to these revenue with an average revenue per patient of $67,564.77 and an average cost per patient of $64,968. 25% yearly increase in term of patients monitored from home. 10% increase in patient throughput. 750 admitted patients year 0. 5% decrease in cost per patient. 4.5% decrease in revenue per patient due to increase in throughput. Cost of capital. Best case scenario equals 3%. Expected equals 6%. And worst case scenario equals 9%. Initial investment costs total $520,100. The 5-year projection shows that software maintenance, remote monitoring equipment, and new employee hire will be consistent costs over the lifespan of the health monitoring system. Training of Barlow's doctors and staff will cost $35,000 the first 3 years. With an initial investment at year 0, the break-even point is at year 3, where the profit curve is about the cost bar. Despite the slight decrease of 4.5% in revenue due to patients' accelerated throughput and the fact that they spend less time at the hospital, our cost is decreasing even faster at 5% per year in average. By year 5 the new health monitoring system will provide to Barlow an excess of capital of over $408,934.19, which makes the project very profitable. In fact, the most pessimistic scenario is at 9% cost of capital. The net present value is $408,934.19 after 5 years, with an internal rate of return of 22%. This worst-case scenario shows that an investor will still profit from a high rate of return over 5 years. The most likely scenario is influenced by a 6% cost of capital. Here the investor enjoys 25% internal rate of return and a net present value of $495,467.86 over 5 years. Most optimistically, an investor will find the 3% cost of capital to bring them a 29% internal rate of return, and a net present value of $594,662.78 over a 5-year period. The Cloud Era Big Data project will be closely monitored by using dashboards in order to keep the project on schedule and within budget. Some of the measures that will be closely monitored are: 1. Budgeted costs versus projected costs. 2. Overdue tasks. This is to monitor timeliness of the project to make sure we are on track to finish the project within the predetermined schedule. 3. Actual cash flow versus projected cash flow. 4. Actual profit versus projected profit. And lastly, patient throughput will be monitored to prove that the big data project will decrease the length of stay and increase patient admittance to the hospital. Performance measure reports and metrics will be reported to the C-suite periodically. This was a presentation of Team 5 with James, Jason, and Axel. Thank you for watching. Any questions?